So here we go. This is about just under 4 inches. I'm using the 0 pinion to tighten, and you can see the reading is almost does not move at this length. So the concentricity is fine. Why? Because I use the proper device. But now if one of the jaws is moving more or it has more play, these two will close before that. So, or the other way around, this can move back, so they come in, but this one moving back, and it will throw this out of alignment, so it's gonna start wobbling that way. It's still concentric here, but the lines of the spindle and the lines of the bar are going different direction. So this has nothing to do with grinding the jaws. This is all to do with how much the jaws are moving, or one move less or more than the other two. So this will throw it out of balance, and you have not only two, it's gonna come this way. The more you come to the front, the more it multiplies. So see, now this is perfect, right? Watch when I move it forward, what's gonna happen. Тест сега. Тук сме. Ако не се вижда зеленото е нулевия пинян. Само това тук. Стягаме жълто. Айде да се вижда. Колко е това? Това е около една стотна. Плюс-минус, вземем 2 стотни. Наоколо. Случи резултата е. Добре. So watch what's happening now. I clamped the bar at the front. Wow, it's way off. Why is he way off? Because one of them is moving more than the others. So the others two pushing this way, and this is locking behind, and it's throwing the whole axis out of line. This is still rotates, but the axe is going that way, and this now is showing like run out, but it's actually misalignment of the two axes, because one of the jaws is moving that way. And the reason why I'm showing this, if you put the ring, these two jaws are gonna push out of concentricity the other one, because this one is locking behind, or it's got more play to come back. So then, when you put a ring and you grind it, you never get this to run concentric, because the other one can push. So in some instances, if the jaws are the same, it will work perfectly because they don't move. So this will work. And somebody will argue, oh yes, but then it works. Of course. But if one of them is moving different than the rest, or it's got less movement or more movement different than the others, when you tighten with this ring, something will happen. When you use this device, the other two jaws, they cannot push this. See, I'm moving here, but this does not move. This can only work on pull. And because it's cut here, the jaw can actually stretch it and still be under load, but does not interfere with the other three. Hope you understand. Right. Another explanation video. So, we got the three jaws and the ring. And the jaws, we checked this movement. If this is moving more or less than the other two, say this is 0.03, 0.03, and this is 0.05. So these two will start to close, and the other is still able to go back. Then this circle is gonna push out of concentricity of the axle of the spindle. And also, what's gonna happen, the jaw is going to tilt back like this, because they're pushing it, right? And then, when you machine, you're gonna machine this out of square. So this is not going to be square anymore. And the rest, they might be square because they don't move enough, but you don't know. So you're introducing too many unknown things. Also, you're gonna do bell mouth, so the jaws are going to stay like that because the ring is pushing them. So they will be like that. And then the grinding tool coming to grind is only going to grind from here to there. So this is not going to be square anymore. Some might say, okay, but we wanted to do it front bias. Yes. But then, when you're clamping something hard, this is going to start clamping before. Okay, on aluminium, this can squash, right? So the jaw will do indentation into the bar. So it's going to be something like this. The door, if the jaw is not square, it's going to indent here more and then we'll touch the rest. But we don't want that. We want it to be nice and straight. And you can feel that when you tighten, you should just tighten sharp. Not start to tighten and you see squashing, because if you got this feeling, then you got a gap somewhere and you close in this gap, you're forcing it. But in this case, this is a chrome bar, so it cannot squash, this cannot indent it. So then you feel the difference. And what I want to show you is this device, right? So in this device only works on pull. You cannot push. So when this goes over the jaws, every jaw is pushing on its own, but it does not interfere with the others. So if one of them need to go forward or need to go backwards, when you tighten, this allows it to move. So this will move until the ring will stretch, and this will move until it finds proper tightened position, and then you machine this. But because it's sort of pushing it in, the middle is not going to tilt as much as it would be when you put the ring. It's still gonna move. That's, you know, inevitable. You cannot not move because there is some play in the jaw. Unless it's some super precision brand new chuck, then it's a different story. But then you don't have to touch it. It's already gonna be good for the touch. But if you don't want to introduce bell mouth to open it, to do this, there is a device. So they don't interfere with each other. So if these two are tightened and the others is not, you just keep tightening until they all come in into the middle of the actual axle on the chuck. And then you grind the rest. You grind there. But if you put the ring will introduce a mistake because this is pushing it that way or the other way, unless you got a ring that is really soft to squash. But then you can't machine inside because the ring is in the way. So you have to put it somewhere, or the front with the pins like this. But the actual forces, when you introduce the force on the top, open this more, or it will move more because you're pushing it there. See, when you push something there, it lifts. But if you push it there, it can't. It cannot lift. That is the difference. See, easy to push, but when you go there, it doesn't go. It doesn't go up because the force is in the middle. And this is a handy device. Hope you understand.